Hello everyone, so welcome back to my YouTube channel, and today we are going to discuss about the basic packet flow in the routing information protocol. That how does the routing information protocol select the best path on the behalf of the hop counts. Okay, so first of all we will provide the IP address to all of these, as we have already labeled the IP address. So now we are going to provide the IP address, then we will do the configuration of routing information protocol. So let's start with the PCs. Okay, 192.168.10.2 is the IP address. So let me provide this, and 192.168.10.1 is the gateway. Let's provide the IP address to second PC1. 192.168.12.1 is the gateway. 192.168.14.2 is the IP address, and 192.168.14.1 is the gateway for the same. Okay, so we have just provided the IP address to the same. Now let's provide the IP address to the router. Okay, configuring terminal. Okay, so go to global configuration mode, select the interface G0/0/0, no shutdown, and IP address is 192.168.10.1. Okay, then 255.255.255.0. Okay, this is the IP address. Now let's provide another IP address interface, SE0/1/0, no shutdown. Then IP address will be 192.168.11.1 and 255.255.255.0. Okay, so we have just provided the IP address to this router. Let's provide the IP address to the middle one. So no, enable configuring terminal interface G0/0/0. Okay, interface G0/0/0, no shutdown. Then IP address will be 192.168.12.1 and 255.255.255.0. Okay, another one is that interface SE0/1/0, no shutdown, and IP address will be 192.168.11.2 and 255.255.255.0. Okay, so we have just provided the IP address to middle one. Now let's provide the IP address to the last router. So go to CLI, no. Okay, then enable configuring terminal. Okay, interface G0/0/0, no shutdown. Then IP address will be 192.168.14.1. Okay, here is the IP address. So we are providing the IP address to this interface now. Then after that, we will provide the IP address to this interface. Okay, SE0/1/0. This is 13.2. Okay, for now 14.1, and gateway will be the subnet mask will be 255.255.255.0. Okay, then let's provide the IP address to another interface. So interface SE0/1/0. Okay, no shutdown. Then IP address will be 192.168.13.2 and 255.255.255.0. Perfect. Okay, so I think we didn't have provided this IP address. So that is why this interface is down. Let's provide this IP address also. Okay, so let's go to the router. Okay, select the interface SE0/1/1/1. Okay, 0/1/1. No shutdown. The IP address will be 192.168.13.1 and 255.255.255.0. Okay, so this is the IP address. So we have just provided the IP address to all of these. Now we will do the routing in that case. Okay, how to do the routing? We have to define the network. If I talk about 192.168.10.1 and 192.168.10.2, these two are the part of 192.168.10.0. So let me mention here 192.168.10.0. And if I talk about the last one, 192.168.12.0 and 12.1, 14.1 and 14.2, these are the part of what 14.0. So let me mention here also, the network here will be 192.168.14.0, and same the network will be 192.168.12.0. So here I have just written that this is nothing like that. The IP address has been provided to the switch in that case. But I only have just mentioned that these two IP addresses are the part of 192.168.14.0. Okay. So now let's do the routing in that case. So now we are going to configure the routing information protocol. So router RIP. Okay. Network 192.168.10.0, 192.168.11.0. So this is only the command used for the routing in that case. Okay, let's do the routing on middle one. Go to global configuration mode, router RIP, network 192.168.11.0, 192.168.12.0, 192.168.13.0. We have defined all the network in that case. Let's configure the last one. Go to global configuration mode, put the command router RIP to configure the RIP protocol, then define the network 192.168.14.0 and 192.168.13.0. Okay, that's all. Now I will forward a ping packet that is called ICMP packet from source to destination. Let us assume this is our source and this is our destination in that case. So all the packet will be forwarded in between them to check the best path. Well, for now, there is only one path to forward the data like this. So the packet will be only forwarded like this. Okay, let me do the same. So let me try to ping this and we'll see what will happen. So go to command prompt, put a command ping 192.168.14.2. So the first packet will be lost in finding the MAC address of the destination. Okay. Now let me show you the packet flow by the help of simulation method in which we can track the packet flow. Okay. So go to command prompt and put a command one ping 192.168.14.2. You can see that ICMP packet will be generated, will be forwarded to the switch. Switch will forward this to the router. Router will forward that to another router, and there's only one part to forward the data, right? If I talk about the number of routers used in between them are three routers from source to destination. Now let us assume I have connected these two routers directly. Now the hop count will be lesser in that case. Okay. Then we will see what will happen. Will it forward the data from that one or will change uh, the path? Okay. So currently, if I talk about the data forwarding is done on the behalf of this path. Let me directly connect it these two routers. Okay. So let me take a serial cable and we'll connect both of these. Now these two routers are directly connected. Here you can see the number of routers are less on that path. So let me provide the information of that, do the routing, and also provide the IP address in that case. So let us assume the network provided to the upper one is 192.168.15.0. Okay, so there will be two IP addresses, 15.1 and 192.168.15.2. Okay, let's do the routing as well as provide the IP address in that case. So go to router. Okay, select the interface SE0/1/1, no shutdown, and IP address will be 192.168.15.1 and 255.255.255.0. Let's provide the IP address to other router also. Okay. Interface SE0/1/1, no shutdown. Okay. IP address will be 192.168.15.2 and 255.255.255.0. So we have just defined the IP address. Okay. Let's let's do the configuration of routing information protocol. Let me advertise the network to both of these routers for this router and this router, and we'll see what will be the effect. Now, will the path changed or not? Okay. So router RIP network 192.168.15.0. We have just defined the network on one side. Let's do the same on other side. Router RIP network 192.168.15.0. Okay, we have just done the routing in that case. Okay, let me fast forward this. And now we will use the simulation method to track the data flow. Okay, let me again forward a ping packet 192.168.15.2. The ICMP packet will be generated. This packet will be forwarded to the switch. and then switch will forward to the router. Here we have two paths to forward the data, this path and this path. Then again the data will be forwarded by this like this, but this path has two three number of routers. Here we have only two number of routers, so number of hop count is lesser in is as compared to path number 2. So this path will be automatically selected because we have lesser number of routers in that case. Okay, let me try to forward the packet. So packet will be forwarded to the switch, switch will forward to the router, but router will select automatically the above path as we can see. So now the best path to forward the data will be this one, not by this one. Okay, this path will not be automatically selected because upper one is having the least number of hop count. So this is how the routing information for protocol select the best path on the basis of what? Hop count. So dear all, if you have any confusion regarding this class, so you can text me over the same. You can also do the comment if you have any confusion. Thanks a lot. Please subscribe my channel. Have a nice day.